Hi and welcome to DCO. My name is David Copete. In today's video, I'll be going over this script. This is perfect for those of you who are brand new to Grasshopper or want an exercise that is practical that they can start with. We'll start by creating the base form by creating a sphere, adding all of the details you see here, and basically hollowing out the dome and creating the door. We then move on to add a little bit more details in terms of creating the door size, having the location for the door shift, and also pick the location and size of trim. So these details is kind of what we continued with, but at the end what I did was organize the script into a cluster where you have inputs and outputs. Now this is the one that if you don't want to see how the whole script was created, this one is the one that you could use, where you have all of the details still here, and we can change all of these parameters to create a completely different design. So hopefully you're excited about learning how parametric design works. We'll start simple and add a little bit more details. So this is perfect for those of you who are new and interested in parametric design. So thank you very much for being here. Hopefully you're excited, and let's jump into it. All right, so the first thing we're going to do is bring in a point. So we'll go here to construct point. What this does is it gives us a point at the origin, and this is where the design is going to be located. Now we can take this point, and I'd like to route it through an empty point component, because what this does is lets us in the future be able to change this point. And when you change this point, then you would change the location. So now let's bring in a circle or a sphere. This point is going to be our base point for the sphere, and then this radius, let's pick that. And so whatever number you pick, you're going to get a range of numbers within a slider. And I like to use 2 decimal points so I can have a little bit of room to change that number a little bit more subtle using the decimal points. But let's say that this is a radius of 50. So this would be 50 feet, which means it's a 100-foot diameter. All right, so now that we have this, now we need to split it so we can use that as a dome shape. So what we'll do is we'll go to this point and create a circle. This circle is going to be also created off of that same point. So then we'll use that same point input as the sphere. And now let's change the radius and use the same number as the sphere. What this does is it creates a circle around that sphere. And now what we can do is split the surface. So now I'll go here to surface, split. And now we can use the sphere as the input and that circle as the curve that's going to cut this in half. So now we can take this, disable preview. Now we have 2 fragments, which the first thing we'll do is extract one of them, because what we're doing is we split this in 2. So now I can go here to list item and pick the first item, which is the top part. And now we can disable the preview on this and just use this part of the sphere. So as you can see, what we've done is we've created a dome shape, split exactly down the middle. And now this is going to give us the base geometry for the dome that we'll be creating. So little by little, what we're doing is starting simple, and then we're going to start building upon the script to be adding more details. And at any point within the script, we can interject any time between and add more details to, depending on whatever we want to do for the design. And so the other thing I wanted to do is, what if we take this sphere and rather than cutting it in half, we make it so it cuts it a little bit lower, or meaning the sphere could be moved up and then trimmed. Now there's going to be a few things here that we need to change. So number 1 is we're going to move the sphere before it was cut. In which direction? Up in the Z direction. So now we can go, let's say, move the dome up by 15.5 or down. So this lets us pick a different location for where it splits it. And now, if we disable the preview here, you'll see that we have this circle and this sphere. Now what happens is this circle is no longer intersecting with the sphere. So what we need to do is turn that into a surface so we know exactly where that intersects with the sphere. So let's go here to boundary surfaces. And now we can split, VREP split. We'll be using the sphere as the input and the cutter as the surface. It's a little bit different than surface split because this is actually using a solid. So now we can disable the preview on everything here and even delete this because this is for the old part. And now we have this list item because now we have two that's been split. We're just going to be picking the top. And now with this configuration, what we've done is we can change the size, we can change where it cuts it, and extract the dome shape. So this one gives us a little bit more functionality, a little bit more detail in terms of creating a different intersecting point. But now what we'll do is we'll take this and we turn this into a solid. So I'll go to cap, holes. What this will do is turn this into a solid. So now we can disable preview here. And now we can hollow out the sphere so you can have some space within and have some wall thickness. So to do that, we can do it two different ways. We know we have the sphere, which is the exact same size as the outside. Now, if we took the sphere and we offset the surface to the inside, so if we went in a negative direction, we offset this by, let's say, 1.5. So that entire sphere has now been made smaller or offset to the inside by, let's say, 2.5. Now I can disable the preview on that sphere. And now we have two overlapping geometries. We have the outside form and we have this inside sphere. So what we'll do now is subtract one from the other. So we'll go to solid difference. The one you want to keep, which means the outside shell, is A, because that's what we want to keep, and B is what we subtract. So A is the yellow and B is the gray portion. Now we can take this and plug that into the BREPS B. So check this out. We've now created a sphere that's been cut down the middle, or using this cutoff. Let's go here to 15. We can change the size and pick the depth of the wall. So now you're seeing that depending on what approach you take, things might be a little bit different. If you're using solids or just surfaces, you might take a different approach. Now with this one, we're creating a solid on the outside and subtracting a solid from the inside. So just make sure you keep that in mind. If you're using just surfaces, you might have some issues. All right, so on this next portion, we're going to be creating the opening. There are different ways that we could do that, but I'm going to show you one technique that is pretty straightforward and practical for those of you just getting started with parametric design. All right, for this next part, for the door, we need to first figure out where the door is going to be located. And where the door is located, then we need to find the geometry that we could use to extract some kind of reference point to create that door. So when we look here, we want to create it obviously somewhere within the wall area, but what we need to bring back is that surface. And let's bring back the dome before it was cut. So we see that we have this dome, this surface. Now we need to know where they intersect. So where they intersect is here in Grasshopper under the intersect tab. Here's where we have where the B-rep intersects a curve, where the B-rep intersects a surface. What we need to do is B-rep and B-rep, which means where this surface intersects this sphere, we want to extract a point. So I'll put it here, or extract a curve. Now that we've extracted the line segment, well, now we can extract a point within that line segment to create the door. So we'll take this, we'll go to, well, let me explain it this way. There are different ways of extracting a point. I'm going to show you the simple way first, and then one that has a little bit more control. So the first way of doing this is point on curve. What this does is it takes any curve, and when you plug it in, it's at 0.5. So it basically reparameterizes this line segment, which means that it converts it from 0 all the way to 1, and anywhere 0.5 is halfway, 1 is at the start, and then 1 here at the end is at the beginning, and then here, or 0 is at the beginning, 1 is at the end, and 0.5 is in the middle. Now what's not necessarily great about this is you can't pick, let's say 0.5, I can't double click and make it 0.5. It's not as accurate. And although it's not accurate, it does allow us to extract a point pretty easily. And it's really graphically nice here, where you can see exactly where the point is sitting. Now that we've extracted this point, we need to create the door. So let's go here to the first point, so 0, and I'll create another sphere. Now the sphere is going to be created on that point, so this output from the point on curve will go into the base input for the sphere. And now let's change the radius. So since the radius is from the middle, 15.5, that's how big the door is here. And we can change this, obviously, depending on whatever size we want it to be. So if we want it to be 20 foot tall, that's how tall it's going to be. Now the thing is, sometimes you don't want the opening just to be halfway to the middle. So in the same way that we moved up the sphere at the beginning, then we want to do the same thing here. So either copy the move vertical here and plug this in. Now it's not previewed, so I will make sure to preview this. And now you see that how this can move up and down, changing kind of that location for the door. Obviously you don't want to go too high up here or else you don't have the ground portion. But this is a way in which we could do it. Okay. So now that we've extracted this new sphere or this point, and then we put the sphere on that point, picked a size and moved it up. Now we can do the same thing that we did with the inner sphere, which is solid or solid difference, and subtract the door from the sphere. So the dome is going to be A, and the door is going to be Ureps B. So now let's disable the preview on all of this, and you're starting to see that now not only do we have a door that we can change the opening and opening size, but we can change the location depending on where it is according to that line segment. All right, let's show you one other thing. Now that we have this location, let's say 0, 17 tall, maybe a little bit lower. Now we can extract another point if you want more doors. So let me show you what I mean. If this is at 0 and this is at 0.5, and we want to create another one, then I'll hold down Shift and add it to the base. And now we have another door, because wherever the point is extracted, we can put another door. Now, if we want them to be across from each other, then this is at 0, and then this would have to be at 0.5. But with this, we have a little bit of a difficulty being accurate, in the sense that I want it to be exactly at 0.5, not at 0.469. So how do we do that? Well, this is how we do it. We're going to go to Evaluate Curve. I'm going to go 0.5000 and then plug in the curve into the curve input. And notice that this moves only by 1 to here, from here to here. We want to reparameterize. So it goes from 1 to 0. So now we'll go here to 0 and override these two. So how do we do that? I'll double click here, and just delete those, because now we have a new point. It's going to be this point. And then if I want it to be at 0.5, then I'll copy this, hold down Shift and add another one, and then go here to 0.5. So if I want add every 4, we'll do 0.25, 0.5, and 0.75. And then we can change all of these sizes at once and even raise them at the same time. Now, if you want it to be, let's say, openings in the sky, that's another way of doing it. But down here, this is how we create that opening. So for now, I'll leave it just with 1. And this lets us be more accurate because we can pick a point between 0 and 1. So with that being said, let's organize this a little bit. And so let's go over what we did today and see how this can be, how we came up with this. So starting with the point, then we move on to the circle, which then is where the sphere intersects it. But then we move it up and intersect it with this surface to extract that line segment, and at the same time have this dome, which then gets subtracted and moved up to create that door. So now I'll bring this back and then create a larger door opening. All right, so with this, you should be able to create a bunch of different iterations, change some of the sliders, and come up with a bunch of different solutions. The thing is, though, if you do want to go a little bit further with this design, I have this additional step that I want to show you, and it's creating the trim around the door. Now, these steps are pretty straightforward as well and pretty practical, but just understand that you want to go little by little. If you've never gone into these tutorials, then I would suggest take your time, but a lot of the things you learn here will be useful for so many different designs. So I don't want to discourage anyone from going further than they think they can. So with that being said, let's start by going back to the beginning and figuring out where the dome is. Now this is the dome location on the outside. This is the dome location on the inside. So we know that. What we need to do now is offset the outside sphere to the outside by whatever the trim amount. So let's say we said 0.250 is what we're offsetting out. And then this is what we're offsetting in. So what we need to do is copy this and offset this one, but in a negative. Why? Because we want to not to go to the outside, but to the inside. So we've got two forms that are offset to the outside and to the inside. What we want to do now is split it the same way that we split the dome. And actually, from what I'm seeing is we may not need the inside one, and you'll see why. So we have the outside one. And now we're going to go to the door. This door was then moved up. So it's this sphere that moved up. We're going to offset this to the outside by more than just 0.25. We want it to be, we'll say 2. So where this sphere intersects this overall form, we're going to extract it. So intersect, solid intersection. We want to keep this outer sphere. We want to intersect with the other outer sphere. So once we disable the preview on these two, you'll see that we have that form, the outside part of the trim. So let's disable the preview on most of this stuff. Okay, now we're going to subtract the inside sphere. So now we'll go to this one, and now this one will be offset to the inside. So copy this, use this as the input, and then we'll bring in a negative component. Now this is what we'll use to subtract from this. So solid difference, subtract this sphere, so that goes in B, from the trim. Now we can disable the preview here. And then lastly, we're going to subtract and split what we had before. So we'll go to split, brep split this, or actually no, before that, we're going to do solid difference. But what happens is the door location, which is this one, then needs to be offset to the inside. Let me show you why. Because that then becomes the trim depth on the inside of the arc. So now that sphere subtracts from this one. Now we'll split it using the same technique that we used for split derep. And it'll be the same cutter because it's the same ground plane. And then we'll use this as the input. Now I'll go to list item because there's two of them. And then cap. So what did we do? We took the original sphere and we offset it to the outside. We took the original inside of the sphere and we offset it to the outside. We took the original sphere that subtracted the door and we offset it to the inside. Then we had a form that we subtracted all that from, and now we have this trim that fits around it perfectly. So let me show you what I mean. This is to the inside. Actually, let me put some color on this. So to add color to this, I usually use custom preview, and I use a color swatch or a color picker. So let's go here to color picker. And then use this output into the material input. And I like to just hide the preview because this is a pretty large component and it just kind of gets in the way. So let's bring this here. And then copy this down. So slide it down, tap Alt, and then plug this. So now we can So how does the trim work? Like you see here, it's offsetting already the information that we had, especially the door. So let's go here to offset 3. So that's the wall depth. And notice that as the wall gets added, you also have the trim going off of that. Then once we have this offset, then we have the trim. How far in does the trim go? I guess that's what this slider does. At 0 or 0.5 to the outside, 0.5. And then this one is on the outside. So what I'll do now is I'll clean this up, probably show you that in a time lapse. And yeah, if you have any questions, let me know in the comments below, or if you want to download this, check out the website. I usually have it available for a limited time, and I can help you answer any questions that you have about this. Like I said, what I'll do now is clean this up, have it as a script, and also simplify it into a cluster for those of you who want to download this. So thank you very much for being here. Hopefully you found this one interesting. We started with a basic tutorial and then made it a little bit more complex by adding this trim around it, but it was using most of the information that we already had. So thank you very much for being here. Hopefully you learned something new, and I hope to see you on the next one.